Now for this, this will take the capacitor, which is having initial charge plus Q naught minus Q naught. The inductor, initially there's no energy. At t equal to 0, I'm going to close the switch. At t equals 0, I'm going to close the switch. Then what will happen to the charge and what happened to the current in this circuit? That is what we have to analyze. Then we have to write some mathematical equations. At any instant of time, let Q be the charge. Some charge across the capacitor start decreasing at any instant of time, let me, or you can write Q naught minus Q. Anyway, let me take this one. This is at t equals 0. At t equals 0, I close the switch. After closing switch, and then what is this? This inductor like a wire, no? So which plate is at higher potential? The upper plate is at higher potential. This is at lower potential. Then what capacitor? Capacitor will see this inductor just like a wire. So I'm connecting a wire from one plate to another plate. So don't say shorted, come out here because some energy is present, no? Here. So and this is the higher potential, lower potential. The positive charge will move from high to lower potential. The charge starts flowing. Due to rate of flow of charge, there'll be current. Say current I starts flowing in the circuit. And according to polarity, this should be plus, minus. In what form the energy was initially? Only capacitor. This is maximum. Energy in the inductor is 0. Now there's some energy in the capacitor and also there's energy in the inductor. You just trace it out, the circuit. In almost all numericals, there's a background is what you needed. How long this will continue? As long as there's a charge in capacitor, there'll be flow of current. So at one instant, what we get is the whole charge in the capacitor or the energy in the capacitor will be available across the inductor. Uh, we show the flux, no, the energy here, and what is the charge across capacitor is 0. So you see 0, UL is maximum. Look at what is the direction of current. The current I was flowing clockwise, no? Very next moment, as long as there was a charge in capacitor, this was behaving like a source. That source was supporting the flow of current. Because of that, there the flux started building up. Some flux started building up across the inductor. Show some flux like this. Then once the charge in capacitor is 0, then there won't be like a support for this current. So then what happened because of no support for current, the flux across the inductor starts collapsing. No? Tell me how the induced current should flow in the direction of I only. So now the current here, the flux starts collapsing. Now the current will be pushed in the direction of earlier current. So let me put I. Of course, the magnitude of current will be different. Let me take time being like this. So because of that, this end will become positive. This will be negative. Now slowly some energy starts building up in the capacitor. How long this will occur? As long as flux is varying. As long as flux is varying. So now finally, the next sequence is the whole flux in the inductor will decrease and finally become 0. Then the charge on capacitor will be plus Q. This will be minus Q. Let's trace out energy. So here UL non-zero, UC non-zero. Now UC will be maximum, UL will be 0. After this, what is the sequence? The next sequence will be one problem, please, all of you do understand. Afterwards, you can manage. Of course, the same conditions, everything will come. You can manage almost every problem. The method is same. This is a capacitor. So charge across this decreases. Now the current will flow in this direction. Why it should be? Because this plate is at higher potential. Now the from the positive charge will flow from higher to lower potential. So as the charge starts flowing out, flux across the inductor will start building up. So for our understanding purpose, I'm just showing some arrows inside that. And this end will be positive, negative. So the next sequence, the charge across capacitor, it has become zero. Now the whole charge, so the whole energy will be there across the inductor. Now here, UL, UC non-zero, UL non-zero. Now the UL is here maximum. You see zero. Again, there won't be how long, why the current will flow? Because of this energy in the capacitor. This will be like a cell. As long as there's a potential difference across capacitor, it will support the current. Because of current, there's a flux, it will start growing here. Now, once charge in capacitor is zero, so there's nothing like there's no EMF, then there won't be support for the current to flow. Then the flux starts collapsing. Now, in what direction the EMF should be induced, or in what direction the induced current should flow? In the direction of initial current. So there's the last part. The flux starts collapsing. It will push current in this direction. So this will be positive, negative. So there will be some flux, and it start decreasing. The decrease in magnetic energy will be converted into increase in elastic potential energy across the capacitor. So here UL non-zero, UC non-zero. And after this, you'll get the sequence one. So I'll put 1, 2, 3, 4, 5. After 8, again come back to 1. And again the process will get repeated. How long this? Yes, forever. As long as there are no dissipative forces are there. No dissipative forces. What dissipative force? The resistance. Of course, we can never get ideal. The connecting wires will have resistance. The inductor made up of a conducting wire will have resistance. So therefore, energy what happen will be continuously decreases. So what type of motion it will be like? It will be like a damped oscillations. What we get practically. I can make it undamped. How much of energy decreases per cycle? That much I'm going to add up. Then it'll become a forced oscillations. Like that, what I can do now, I can generate electrical oscillations. So when I say oscillation, so definitely I'm interested in the frequency, the time period. So what is the frequency time period of oscillation? Don't say that capacitor inductor oscillating. No, the current and the charge are oscillating. So what we are discussing is electrical oscillations, not mechanical oscillations, electrical oscillations. Capacitor and inductor, they're fixed here. They don't vibrate. The charge and the current are vibrating here. And I think it's one of the teacher asked like this. In a LC oscillation circuit conducting capacitor inductor, charge current oscillates. Elements, their passive elements. These are called as passive elements. Capacitor inductor. Passive elements oscillate. It's there in one of the mains paper. Some of the students went even for capacitor inductor vibrates. No, the elements will not vibrate. No, here you have to be very careful. It's not that almost maximum 70% of students went wrong. So unknowingly, suddenly that question will come, will be in a because else everything will oscillate is what we say here. All the electrical quantities oscillate, not the L and C. L and C are the passive element. They are physical elements. They don't oscillate. Like this, the charge and current will oscillate. So I want to find out the time period of oscillations here. So for that, let me take this equation. Now how they are connected? They're connected. Look at the second diagram, or you can take fourth diagram. So like the drop across capacitor be VC. The drop across inductor, let it be VL. VC is equal to VL. What is VC equal to? Q by C. VL equal to L di by dt. Now the charge across capacitors start decreasing. No? So therefore I'll write I equal to minus dq by dt. So this will become QLC. A general equation of SHM, if you compare this, so this should be equal to minus omega square q d square q by dt square, no? From the SHM equation. So therefore what is omega square should be equal to 1 by LC, or omega equal to 1 by root LC. As we know omega equal to 2 pi f. So what is the frequency of oscillation? 1 by 2 pi root of LC. Denominator. I'll write it here. F is equal to 1 by. So the frequency of oscillations, of elliptical oscillations set up in this circuit depends on what? Depends upon the value of L and C. By just varying that one. Where is the, where do you use? This is the oscillator. See, like we want to have a frequency, no? We want electrical signal of definite frequency. Suppose say for mobile, we use around 200 megahertz electrical signal of frequency 200 megahertz. Then if you go for that's radio communication, this one FM band, we use around 88 megahertz to 100 megahertz. How do I generate that electrical signal of that frequency? By using this circuit. There's another name for this is called as a tank circuit. What do you mean by tank? Water tank. What it does? Supplies water. So this will supply the electrical oscillations. Practically what happens? Because of connecting wires, resistance of connecting wires, an inductor will not be ideal, and there will be the dielectric slab which is there between the plates will have some resistivity. Because of that, there'll be resistance. Like this, I should bring practical tank circuit, equivalent circuit of practical, it will be off like this. Huh? Capacitor will not be ideal. So here I should show like this. This is the resistance of capacitor. Then there's an inductor. Then inductive resistance, RL you show it. This is what the practical circuit will be. So and as as the charge or as the oscillations are set up, these RL and RC are what? Dissipative elements. What about capacitor inductor? They are energy storing elements. They store only energy. Inductor will store energy in the form of magnetic field. Capacitor will store energy in the form of electrostatic field energy. So, but what about the resistors? They are the dissipative elements. They will just dissipate the, whenever current flows it will be generated. For every one cycle, some energy will be lost. How much of energy we lost, I'll supply it back. Like that, when oscillations are sustained, undamped oscillations, I'll produce it. From here, I'll put like a mutual inductor. With that, I'll take back that oscillation energy. Like that, I can generate an electrical signal of desired frequency. By adjusting value of L and C, I can generate electrical signal of desired frequency. They may test you with this one. This is a practical LC oscillation circuit. We'll just confine to ideal case. This is a practical one. This is due to resistance of dielectric slab. This is due to inductor RL. Now, what are other things? So let's get expression for charge current, because as it is oscillation SHM, so definitely harmonic things will come into picture. So then solving this second order differential equation, I'll end up Q equal to Q naught sine omega t. Cos omega t. What is omega? Omega is this much. Q naught is initial charge given. How to give that charge? That depends upon other things. From RC circuit, I'll bring this charge Q naught off by connecting a cell. Let me differentiate this. dq by dt. So minus Q naught omega sine omega t. So what is I? I equal to minus dq by dt, no? So what is the expression for current? q naught omega sine omega t. I'll differentiate again, di by dt. This should be equal to q naught square omega cos omega t. This is charge is similar to displacement. Current is similar to speed or velocity. Di by dt is similar to acceleration. These are the terms which we are going to correlate. Take help of the, already we know SHM, no? From that is what I'm trying to get this one. So therefore from here, what is the expression for current? So shall we sin omega t? I'll write it as cos omega t. So this should be the q naught square. So what is the expression for current now? Current in the omega equal to, similar to SHM equation, V equal to omega root of a square minus x square. So that q naught is what? Similar to amplitude. So you have to maximum take help of the SHM ideas. So I is equal to omega this one. Then can I conserve energy? Only when circuit is like this, you should not do this one because some energy will be dissipated. So therefore now by applying initial energy in the circuit, q naught square by 2c should be equal to energy at any instant, q square by 2c plus L I square by 2. This is the oscillation energy. What is q naught square by 2c? This is the oscillation energy. We'll call this as, this is the oscillation energy. Now what do you mean by oscillation energy? The energy what we feed to the circuit, or the energy what we give to the circuit. With that what it will continue, like in SHM. What is oscillation energy? Spring block system. You are going to displace the block, no? And so the spring will get elongated by x naught. Then how much of energy is there in the system now? K x naught square by 2. That is oscillation energy, and that will be converted as elastic or kinetic energy of the spring block system. Similarly, this is what oscillation energy supplied. And we know how to charge a capacitor. So quite very simple, that one. Then what is Q? Charge at any time. I is the current. So if you know charge, you can bring also the current, or you can take help of this mathematical equations.